Good afternoon, everybody. Happy Tuesday. Happy Tuesday. We don't want that. We want. I didn't even know he had. All right, we're trying to admit everybody. We're going to look at 4.7 today. Hopefully, most everybody has worked on their watershed activity. Uh, watershed is the last, let me make sure before I say that, is the last thing that is going to be on this 9-week report card. Yes. Like I said, most of you have finished that, so a couple of you still have to turn that in. So please make sure that you do. And I'll probably say that again because I got a handful of people just now coming in. Okay. Good afternoon, good afternoon, good afternoon. If you're just coming in, I was just saying that 4.6 is the last thing that's going to be on the 9-week report card. So if you haven't completed Watershed, as far as the assignment is concerned, the other part of Watershed, the AP Classroom out, that'll go on the next 9 weeks. So we're going to do AP Classroom for 4.6 and 7 after this report card. So the last thing that should be in the grade book for this 9 weeks will be the Watershed of Georgia. So make sure that, like I said, a couple of people still have yet to turn that in. Today we're going to look at 4.7. So if you going to pull that up in Canvas and take a look at that. As soon as everybody's in, we'll look at that. It's a lot going on in 4.7. Even though it looks short, it's got a lot going on. All right, Zoom does a funny thing. If you're ever sitting out waiting to get admitted, it's not that I'm trying to admit you, it's Zoom does its own thing. Sometimes it admits people twice, and sometimes it just takes forever to admit you at all. It'll say joining, and it's spinning round and round. So I don't know what's happening with Zoom. All righty. So again, if you would take a look at 4.7 for a few, talking about solar radiation, which is a total skip from Watershed. We'll take a look at that and we'll pop back and talk about Watershed in a few minutes before we go on to talk about radiation and seasons. Okay. Like I said, I'm still trying to admit folks. I'm looking. How many of y'all are going to Shine tomorrow? Because that'll determine if I see one hand. Anybody else? Two, three. Only three people? All right. All right, Francisca, you're in. Hi, good afternoon. Good afternoon. There you go. Been trying to admit you for a while there. Like I see you here and it's still telling me you're joining up here. Zoom is not behaving. All righty. Okay, so I was just saying to the folks, as far as watershed is concerned, a few of you still have to turn that in. Up here, I asked, this was one of the questions I asked about our Chattahoochee River. It was one of the questions on your Georgia thing there. That the Chattahoochee River is the one that services your area. So you get your drinking water. This is your source of drinking water, the Chattahoochee River. And it borders Alabama and Florida. And our little water war was about the Chattahoochee River and who's pulling more water from it than the other. And then the fact that we tried to build a dam and that kind of regulated how much water was going to the other two states. So it was a big to-do for a long time. So they've kind of settled it and kind of not. All right. So again, the big thing about watershed is it's usually connected to all the other activities that we have to do. So you see right here, the farm is dumping into the watershed. The city is dumping into the watershed. The water treatment plant is dumping into the watershed. The runoff from the hills and the mountains are dumping into the watershed. So the best water is the water up here at the top. By the time you get down here, it's kind of polluted. So you have to be aware of that, which is, and the Mississippi one is a particular one that goes into the Gulf of Mexico, and there's an estuary there. But the issue is, again, all the stuff, the Mississippi River is a very long river, and there's a lot of cities along the Mississippi River. So by the time it gets down here to the Gulf of Mexico, it's not the greatest water that's being pumped into the Gulf of Mexico. All right, so you need to look at this area right here. You need to make sure that you are aware of all of the things that can do to preserve our watersheds. All right, so today we're going to go ahead and get started on today. I think we're only missing 3 people. They're late. All right, so again, if you haven't turned in the watershed, I had 4.7 today, which deals with the Earth's seasons, which has a lot to do with the tilt of the Earth and the radiation from the sun. So it also includes talk about what is in the light. So we need to talk about the electromagnetic spectrum. So we'll get into an activity with that later on. You got some very distinct vocabulary words here. So I'm going to let Mr. Smead go ahead and do his thing and then come back and let you look at that.
University of Phoenix is
I
built
thought by
for
putting
real
it in the
life.
class
At some
list,
schools,
it
to
would
save
take out
money,
the
you have to move
commercials, but it
fast and
doesn't.
load up on courses. We keep it simple. Take one course at a time with fixed, affordable tuition. Get started at phoenix.edu.
We Buy Any Car makes selling your car fast, safe, and fair.
Here we go.
Book an
Hey everybody, it's Mr. Smeeds, and today we'll be covering topic 4.7, which is solar radiation and seasons. So before we get into things, we need to know that the term insolation refers to the amount of solar radiation or energy from the sun's rays that
All
are
right,
reaching
so like I
an
said, with
area.
this unit, there's a lot of vocabulary that you're going to need to make sure you tuck under your belt. So keep track of vocabulary words.
So because it's the amount of energy reaching an area, we measure it in watts per square meter. So we could figure out the insolation of this little landscape that we have here by measuring its size in square meters, and then measuring the number of watts of sunlight coming in, and then we would divide the watts by the number of square meters. And so now that we know what insolation is, we'll be talking in today's video about the factors that influence insolation. Our objective today is to be able to explain how the sun's energy affects Earth's surface, and in order to do that, we need to know that insolation depends on season and latitude. We also need to know that the angle at which the sun's rays strike Earth determines the intensity of solar radiation, and that this is highest at the equator. And then finally, we'll cover how the tilt of the Earth on its axis while it orbits around the sun is responsible for the changes in daylight, insolation, and season throughout the year. The science skill for today is to describe the characteristics of an environmental concept represented visually. First, we'll cover how solar intensity is affected by latitude. So latitude, you want to remember, is just the distance we are from the equator, and we measure it in degrees. So the equator is 0 degrees latitude, and the north and south poles are 90 degrees latitude, and you increase in latitude as you move away from the equator.
Okay. Latitude and longitude are important vocabulary words. It's important that you understand which one is which, because it has a lot to do with the intensity of the sun. Good morning. Good afternoon. Just came in. We are on 4.7.
Now, we probably know that the equator receives more sunlight than the poles just from thinking about what grows there, what the temperature is like. But the two factors that actually determine that fact are the angle of the sun's rays and the amount of atmosphere that the sun has to pass through before reaching Earth's surface. So because of the curvature of the Earth, the equator is basically perpendicular to incoming sunlight. This means that the sunlight is more concentrated on a smaller area, meaning that the solar intensity or the insolation is higher. So we can see that fact if we look at this small diagram down in the bottom left-hand corner of the screen. So near the equator, the rays of the sun that are coming in are striking the Earth at basically a perpendicular angle. So they're arriving in a far more direct manner, and we can see that here as it's concentrated in this small little area, versus when we go to higher latitudes, we have a far more oblique angle. And so what that means is that the same amount of sunlight is spread over a far greater size of area, and that's going to result in a lot lower intensity of insolation. The second factor determining insolation is the amount of atmosphere that the sun's rays pass through. So we'll see this a lot more clearly on the next slide, but we can get a sense for it here because if we look at the sun, it's passing through far more atmosphere at higher latitudes, and so more of its energy is absorbed or reflected by the atmosphere, meaning less of it is making it to Earth's surface. So at higher latitudes, less insolation is actually striking Earth's surface, and it's spread out over a greater area, which reduces its intensity. Now we'll take a look at a diagram that will help us visualize the effect that more atmosphere has on solar intensity. So if we look at this diagram here, we can see that near the equator, the sun's rays have to pass through a lot shorter distance of atmosphere, and they're concentrated over a smaller area here. However, if we look up at a higher latitude, we'll see that the sun's rays have to pass through a much further distance of Earth's atmosphere, which scatters a lot of the energy coming in from the sun and results in just lower levels of insolation reaching the surface. And when that insolation does reach the surface at a higher latitude, we can see it spread out over a much broader distance. And remember that insolation is watts per meter squared. So with more square meters for those watts to be spread over, the insolation is much lower. So this is going to result in the equator having a much higher average insolation per year. It's about 400 watts per meter square on average throughout the year, versus higher latitudes, which can receive as little as 200 watts per meter squared throughout the year. So we see a vast difference in the amount of insolation received at different points on Earth based on the angle of insolation and the amount of atmosphere that sun has to pass through.
Hands-on, innovative, and high quality. Earn a degree, certificate, or micro-credential online.
Next, we'll look at how the tilt of the Earth changes insolation throughout the year, giving us our 4 seasons. So because the Earth stays tilted at about 23.5 degrees on its axis as it orbits the sun, any given location on Earth will experience a change in the angle of the sun's rays, and therefore a change in its insolation throughout the year. So this gives us our changing day lengths, our changing seasons, and even the temperature patterns that we're used to seeing on Earth. So if we look at the diagram here, it'll help illustrate this point. So on the June solstice, the northern hemisphere is maximally tilted toward the sun, which means it receives the most direct insolation at any point in the year. This gives us our longest day of the year in the northern hemisphere, which of course means that we're starting summer. On the December solstice, however, you can see that the northern hemisphere is now maximally tilted away from the sun. That means we have our shortest day of the year, and it's our first day of winter. Meanwhile, the southern hemisphere is in its summer, and it's enjoying the longest day of the year. You'll also notice in the diagram here that the equator is not receiving the most direct sunlight on the solstice. The sun will actually be most direct fixed on a position about 23.5 degrees north or south of the equator, and we call these the Tropic of Cancer and the Tropic of Capricorn. So because the Earth is tilted 23.5 degrees on its axis, when we have the June and the December solstice, its angle of most direct sunlight is going to shift to 23.5 degrees north or south, depending on the solstice. During the equinoxes, which happen in March and September, both hemispheres are tilted equally toward the sun, and both experience 12 hours of daylight. This is when we experience spring and fall. And you can remember this because equinox sounds like equal, and equal means both hemispheres are receiving equal insolation. So now we'll take a bit of a closer look at the same diagram with a few additional labels. I want to point out, though, that instead of memorizing what happens at each of these 4 points in the year, I want you to think about how the tilt of the Earth changes the location of most direct sunlight, or the angle of insolation. It's this change in the angle of insolation that actually causes the seasons to change. So in December, the northern hemisphere is tilted maximally away from the sun, which lowers the angle of insolation for us, meaning the sun's rays are more spread out over a larger area, and they pass through more atmosphere, which gives us less insolation. This means we get less daylight, and it's the start of our winter. Meanwhile, the southern hemisphere is receiving the most direct angle of insolation, giving them longer days, and the start of their summer. When we move over to the March equinox, though, now both hemispheres are equally tilted toward the sun, so they receive equal angles of insolation, they get equal amounts of daylight, and they're both transitioning from summer to winter or from winter to summer.
Increasing energy resilience.
It's actually already happening, step by step.
Can't get rid of this one.
Why sell your car at WeBuyAnyCar.com? Because selling it yourself can be...
The final thing we'll talk about today is albedo, or the portion of light that is reflected by a surface. So this doesn't have an
Vocabulary words, so make sure that you get this one under your belt as well.
impact on insolation, or how much solar radiation an area of Earth's surface receives, but it does determine how much of that incoming solar radiation is actually absorbed by Earth's surface, and therefore its temperature. So surfaces with higher albedo reflect more light and absorb less. A mirror has complete or 100% albedo, meaning that all of the light striking the surface of the mirror is reflected, and that's why you can see yourself in a mirror. Since absorption of sunlight causes surfaces to heat up, surfaces with high albedo like snow and ice absorb less heat than low albedo sources like water. So if you look at the diagram here, you'll see that the yellow arrows coming off the ice and the water represent the percent of light reflected, or the albedo. Meanwhile, the red arrow represents how much light they absorb, which also represents how much heat they absorb. So this is one reason why the North Pole and the South Pole are so cold. They're covered by snow and ice for much of the year, so they reflect a lot more sunlight than they absorb. This means they're going to absorb less heat than regions of Earth that have a lot more land or water, which have lower albedo. So with our understanding of albedo, we'll talk about how it actually influences surface temperature now. So when a surface absorbs sunlight, it gives off some of that energy as infrared radiation, which is heat. So the more sunlight a surface absorbs, the more infrared radiation it gives off, and the hotter that surface will be. Think about wearing a white shirt in the summer versus wearing a black shirt in the summer. The white shirt reflects a lot more sunlight, so it's a lot cooler, while the black shirt absorbs most of the sunlight, so it gives off infrared radiation, and it's hot. We can see this demonstrated in something called the urban heat island effect. Urban areas with lots of dark surfaces like blacktop and asphalt have very low albedo, meaning they absorb almost all of the incoming solar radiation. And this means that they give off a lot of infrared radiation, making these areas much warmer than surrounding rural areas that have more vegetation, even at the same latitude on Earth's surface. So even with the same incoming insolation, urban areas are hotter because they absorb more of that insolation, whereas rural areas have a lot more trees, grass, water. These things reflect more of that insolation than blacktop and asphalt. All right, our practice FRQ for 4.7 today is to take a look at this diagram here and then identify which season is taking in the northern hemisphere based on this diagram, and describe how the tilt of Earth's axis is responsible for Earth's seasons. All right, everybody, thanks for tuning in today. Don't forget to like this video if it was helpful. Subscribe for future.
Okay, so just like with the watershed, I probably will have another activity for you to do on seasons. So I will not be assigning that FRQ from this one. So 4.6 and 4.7, you won't have FRQs, but you'll have another assignment. So the watershed one was for 4.6, and I'll post another one for 4.7. All right, so go ahead, and it's like the end. So anything that you might owe that you definitely need me to grade before the report card, you can do it today. Today's absolute deadline. If not, go ahead and work on 4.7 in the AP classroom. I believe it's already assigned. Let me check. Or finish 4.6 if you haven't done that. I will not create any new assignment for tomorrow since some of you will be missing. It'll still be finish up 4.7 and anything that needs to be done. I said most of you, I said most of you, there's still a handful of you who need to do that Georgia watershed activity. So please make sure you get that done today. And then anything else you have outstanding, please check on that. If there's something that's not open that you need open, please let me know today. After that, everything else goes on next semester. So 4.7 activities will go on the next quarter. It's not semester, quarter. Give me a minute. All right, it has not been assigned, so let me do that. And since it's not assigned, it may not let you in right now. So let me see if I can. It just said 0 videos are assigned. So All right, you should be able to get into the AP classroom. Let me know if you cannot. I think we're back on the same time schedule, even though there says 11:51. At least we're not behind their time. We're ahead of it. So, uh, Okay, so in place of the FRQ for seasons, we're going to do the Gizmo Lab. So if you want to, if you're in a place that you can get started on it, you can. Otherwise, it'll be something that they'll work on tomorrow. While the Shine activity, oops, the document's not ready yet. At least for me, it isn't. However, all right, there it is. All righty. So in place of FRQ for this one, you will do the seasons gizmo. Rick, I have not added to your class. Amelia. All right, folks. If you're in a good place to stop, you may stop, or you can keep working, but you may also log out. I'm going to log out because today's tutorial day, so folks will start logging in. I don't want them to disturb you. So you may keep working. If you have a question for during tutorial time, log back in. Other than that, I'll see most of you tomorrow. Have a good afternoon.